Today we're going to talk about average rate of change. So when we have a graph of a function that is nonlinear, we can find the average rate of change between 2 points by determining the slope of the secant line that passes through those points. So let's look at the example f of x equals x squared. And we're just going to look on the interval from x1 equal to 1 to x2 equal to 2. So just right here where x equals 1 to x equals 2. I'm going to begin by drawing the secant line that goes through those 2 points, which should look something like that. Should be a straight line. And we can find the slope of a line by doing the rise over run on our graph. So let's count from point to point. Where x1 is 1, we're going to count rise 1, 2, 3 units, and the run is 1 unit. So our slope is 3 over 1. Now there's also an algebraic formula to find the slope of the secant line, which just says f of x2 minus f of x1 over x2 minus x1, which should look very familiar to us. It's a lot like our slope formula, y2 minus y1 over x2 minus x1. To get these f of x2 and f of x1, we're simply evaluating the function at x2 and x1 respectively. So let's look at our same function. Determine the average rate of change of f of x equals x squared, again from x equals 1 to x equals 2. So looking at our formula, I can go ahead and fill in my x2 and x1 because I know those values. It says x2 is 2, so we'll fill that in, and x1 is 1. Now, in order to find this f of x2, we know we have to fill in at f of x2 is 2, so we're going to find f of 2. So I fill in 2 wherever I see x, and I get 2 squared is 4. So f of x2 is 4. Similarly, I can find f of x1 by filling in 1 for x, and I know that 1 squared is 1. So when I simplify, 4 minus 1 is 3, and 2 minus 1 is 1. So again, the slope is 3 over 1, whether we do it graphically or we write it out algebraically.